So, I got a request to do a video on how I wind coils. Seems a kind of a mundane thing to ask. I mean, it's really simple, but let's get started. So first, before you wind anything, you're going to want to know what core you need. So I've got 3 here. This is one that came out of a computer power supply. This is one that came out of a common mode filter choke. And this is one that I bought. So this one was on the output side of a computer power supply. Now these are good for filtering out RF and other unwanted high frequency noises. These are good for pulse transformers and gate drive transformers. And these are good for if you want a bit more power. Now I know this one is an N30 grade because that's what I bought. I'm not sure what the grade of the other 2 cores is, but anyway, let's see how to wind one. So here's how we wind a core. Now rather than just using one strand of wire, we're going to use 2, and they're both going to be connected together in parallel. So these 2 ends will be connected together, and also these 2 ends will be connected together. So you take your core. Now this is one way you can wind it. So we thread our wire through there. Then we take our other end. It doesn't really matter too much about which direction you go. Hopefully without the wire deciding what it wants to do. We thread the wire through like this. I think I was out of the camera shot then. And we just keep going like this. And so on. So why am I doing 2 wires around the core instead of just 1 wire? I mean, all we're doing is making an inductor here. Well, the thing is, having 2 wires instead of 1 helps the magnetic flux. This is also a good technique when making the primary on a gate drive transformer. And just every now and then you want to flatten the wires out. Make sure they're nice and firm against the core. Obviously not putting too much pressure so you crush the core and break it, but I'm not exactly sure how far this wire will go, but this is just for demonstration purposes, so it's not really going to matter too much. This probably won't have much inductance because I don't have very many turns on here, and also because of the core I'm using. I think that's about as much as we can fit onto this core with this particular, well, as far as this wire is going to go. And you just want to spread out your turns nice and even. Again, I didn't realise I was off to the side. I thought I was in the middle of the shot, but I wasn't. And there you go. There's one fresh wound inductor. You definitely want to get yourself one of these if you're going to wind coils. This can measure inductance, and it makes your life just so much more easier. So I'm just going to stick this across the terminals, and let's see what we have. And this is 5.7 microhenry. Now, the number of turns that you use isn't the only thing that determines the inductance. Like, for instance here, I have another coil. It's about the same amount of turns as this, and let's just measure this one. And you can see this one is about 209 microhenry. And that's not because this one is smaller, it's because of what material the actual core is made of. So that's one way you can do it. And there's another way you can wind the wire. So let's take another 2 strands of wire. I'm going to put one end in my vise, and we're going to twist these wires around each other, which is what this drill is for. So I'm just going to stick the other 2 into the chuck. Make it nice and tight. And then winding the wire up so they're twisted around each other like so. Sorry that a lot of it's out of the shot. I'm looking at what I'm doing rather than looking in the camera's viewfinder, so quite often I don't know some of these things are out of the shot. But anyway, we've got two wires twisted around each other. So let's make an inductor with these twisted wires. So again, it's the same technique. Just wind it around the core, like so. Just stopping every now and then to make sure that it's nice and flat against the core. Doesn't matter too much how much the wire hangs out in the middle, that won't really affect the performance. Although you do want to get the inside and the outside as close to the core as possible. So that's about as much wire as we can wind onto this core. So I'm just going to spread out the turns so they're nice and even. So there we go. There's our inductor wound with twisted wire. So let's get the inductance meter out and measure it. Right, so here's our core we just wound. Let's see what this one comes to. As you can see, it's about the same as it was when we wound it with the other style of wire. And of course there are other types of wire you can use to wind your cores with. So I've got a piece of 2-core cable here. You know, the stuff where there's 2 wires stuck to each other. So let's wind that around this core. And I'm going to use exactly the same technique as before. Let's give this a little bit of a wind. And if you're seeing pencils right at the edge of the screen, that's because I'm using those to mark where the camera's field of view is, so I don't do anything off camera anymore. This core is scraping away at some of the insulation while I wind, but there we go. Let's just spread those out nice and even. And that's how you do it. And you can use an inductor like this in, let's say, a buck converter. So on the oscilloscope, the blue trace is what's going into the inductor. The yellow trace is what's coming out of the inductor. And as I adjust the duty cycle, you can see we can change the output voltage. As I decrease the duty cycle, the output voltage goes down. And as I increase the duty cycle, the output voltage goes up. So let's wind ourselves a gate drive transformer. Now I'm using a core that came out of a common mode filter choke. These usually make good gate drive transformer cores, or you could just simply buy your own. And I recommend if you do buy your own cores, you get N30 grade and no bigger than about 23mm diameter. So to get one of these, you can find them pretty much a lot of electronic equipment. Here I've got an old computer power supply, which I'm sourcing for parts. And you can see we've got 2 plastic things right here. These are where the common mode filters are. So all we need to do is take these out, get the wire off, take off the plastic shell, and there you go. There is your core. Now, like I said, you might not always get lucky with these, but for the most part, these work pretty well. Some of them don't, but most of them do. So, I've got a suitable core and 4 strands of wire. 2 of these strands are going to be used as the primary, connected in parallel. So it's like having 2 primaries connected in parallel, and the other 2 are going to be our secondaries. Now, what we're going to do first is we'll just try it with the wire not twisted around each other. So let's just wind this into the core, and this might take some time. So I don't really want to break this core because this is one of my really good ones. And I shall be back momentarily after I have wound the wire onto this core. Well, here is our finished transformer. It's a little bit messy because I was trying to do this for quickness. So let's just measure the inductance. It's going to be pretty big because of the amount of turns and the core I've used on here. I'm not exactly sure how many turns I've put on here. It doesn't really matter which wires you measure. They'll all be the same, since this is a 1-to-1-to-1. And you can see this is about 1.2 millihenry. I told you it was going to be big. So let's just measure the leakage inductance. So I'm going to tie one of the secondaries together. Let's do that to the blue. Again, doesn't matter which one. So let's measure what we get now. We shouldn't have much. Yeah, we've got about 0.8 microhenry leakage there. It's a little bit higher than what I'm comfortable with, but should still work alright. I'm just doing this for quickness. You can take more time while winding these and you'll probably get better results. Anyway, like they say, the proof is in the pudding. So here's that little transformer that I wound on the breadboard. So let's give it a signal and let's see what we get. And look at that. Flawless. So let's make a gate drive transformer with twisted wires. So I've got my 4 wires. One end is in the vise and one end is in the drill. So let's just give them a twist. Make sure they're nice and twisted together. I wish my voice wouldn't do that. It's so annoying. Right, so I've got a core. This is the same core as before. I just took all the wire off it. And let's wind these wires onto the core. Good thing I'm time-lapsing this part, or you'd all be bored stiff by now just watching me do this at normal speed. You're probably bored stiff already, but I'm doing this video as a request. So there we go, there is our transformer, wound with the twisted wires. Let's see how it performs. Well, here we are with the gate drive transformer with the wires twisted around each other and then wound onto the core. So let's see what this one gives us. This was very hard to get into the breadboard. It was very reluctant, but got there in the end. Like before, it's pretty much flawless. And just for kicks, let's see how well a completely unsuitable core performs as a gate drive transformer. Yes, that's pretty bad. And finally, let's see a good core with not the best choice for wire wrapped around it, an unknown number of turns, and this big plastic thing shoved in the middle to stop the thing from unraveling. So, used shielded audio cable using the screen as the primary and the inner wire as the secondary. Let's see how this performs. And yeah, there's pretty much nothing to complain about there. Let's go all the way up in frequency. It's looking pretty good. Anyway, I hope that's unraveled the mystery of how to wind cores. Now I've got to get on and do some more electronics experiments. So until next time, goodbye. Weeble wobble clem alert. I'll take of this video, but first I am going to I turn the exposure down because it's too much. That's better, we can actually see the colours now. So, let's conduct a drive image with the thing. So, let's construct a gate drive transformer, winding the windings together. So, let's construct a gate drive transformer, winding the turns together. No. So, let's construct a gate drive transformer with the wires twisted together. So, I've got 4 wires here, one of which has decided it's not going to stay in the vise.